previous mini lectures described the three options for a preganglionic fiber to synapse with a postganglionic fiber in the sympathetic, well, in all of the nervous systems. We realized that preganglionic fibers are always myelinated, they are all cholinergic, and they all release acetylcholine. There are nicotinic receptors on every single postganglionic fiber in both the sympathetic and parasympathetic nervous system. These nicotinic receptors, they allow the postganglionic fiber to be excited using acetylcholine from the cholinergic preganglionic fiber. What's different with the sympathetic nervous system is that the postganglionic neurons can either be cholinergic or adrenergic, as you see here. The cholinergic postganglionic neurons release ACH, connect to muscarinic receptors, and excite. The adrenergic postganglionic fiber will release norepinephrine, connect with adrenergic receptors on the target organ, alpha or beta, and excite or inhibit. Unfortunately, there is yet another option for releasing norepinephrine to reach target organs. The adrenal medulla, which is like the juicy inside of your adrenal gland, it functions somewhat like a big, huge postganglionic neuron. And as you can see here, it releases norepinephrine and is capable of being excited by a neuron that is releasing acetylcholine. Adrenergic postganglionic fibers can release norepinephrine, and we've not yet discussed this type of release from the postganglionic neuron, but we have discussed how a cholinergic postganglionic neuron uses acetylcholine to connect to nicotinic receptors. So more epinephrine or norepinephrine can only connect to adrenergic receptors and affect their target organ. But depending on the type of adrenergic receptor, alpha or beta, the effect could be excitatory or it could be inhibitory. These were the receptors that were classified into alpha and beta, and we've discussed those alpha and beta blockers. When norepinephrine is released into a synapse between the adrenergic postganglionic neuron and its target organ, there are three fates of norepinephrine after it excites or inhibits its target organ. Just like any neurotransmitter, the preganglionic neuron can suck up or reuptake your norepinephrine, and it can load it back into vesicles for release at another time. Norepinephrine can also, it can just like wander away or diffuse away from the synapse. In that case, it's most likely going to get broken down by an enzyme. But norepinephrine, there's a third option. It can also enter into the bloodstream, and that's because it's longer lived than ACH. When it enters into the bloodstream, it's then going to circulate for a few minutes. And in these few minutes, it means that the norepinephrine can have sympathetic effects on any target organ, any organ that's capable of having the receptors. So because norepinephrine is capable of entering into your bloodstream and circulating, it also means that it can affect organs that are not innervated with sympathetic postganglionic neurons. It can affect organs that are not hardwired to the spinal cord. Norepinephrine, while it circulates for a few minutes and it contacts with any alpha and beta receptors that it can find, and eventually it becomes degraded by the liver. So thinking about how norepinephrine has the ability of circulating in the systemic system for a couple minutes, it leads us to the special case of the adrenal medulla. The adrenal medulla is made of cells called chromaffin cells, and these are cells that are connected to neurons, but these cells are capable of secreting norepinephrine and epinephrine in a much larger capacity than one individual neuron. So chromaffin cells in the adrenal medulla are like really huge and really powerful postganglionic neurons. There are neurons that originate in your hypothalamus, and they use the descending white columns, travel down your spinal cord, leave the spinal cord by way of the ventral root, spinal nerve, ventral ramus, and then these neurons, they reach all the way to the adrenal medulla. The neurons reaching the hypothalamus to the adrenal medulla, they're like any other sympathetic preganglionic neuron. They're myelinated, they use the splanchnic nerve root, and they reach the their target organ. Once they get there, the action potentials stimulate the chromaffin cells to release massive amounts of norepinephrine and epinephrine, which then will circulate in your blood for a few minutes before being degraded by the liver. This is what creates that sinking feeling in your stomach when you're threatened and there's this massive release of epinephrine and norepinephrine. This is also why an adrenaline rush can last for a few minutes rather than a few seconds as norepinephrine and epinephrine last in a synapse.